Okay, so we're moving on to activity 2, which is called Interpreting A over B. So if you recall, the name of this lesson is A New Way to Interpret A over B. This is not completely new. We've talked a little bit about this through the past few months when I have written a division problem using fractions, but this is the first time we're going to talk about it explicitly. When we first learned about fractions, we learned that the denominator told you how many equal parts of something you had was split into, and the top number, the numerator, told you how many of those equal parts you had. So for example, if your fraction was 2/3 of a pizza, you might think of that as a pizza split into 3 equal parts and you had 2 of them. But as we're moving into pre-algebra, we are going to start interpreting one number written over another number a little differently. We want to interpret it as division. So A over B would actually mean A divided by B. And this is in algebra, this is just a much more concise way of indicating division. Okay. So, and the other thing I wanted to point out, this activity simply states solve each equation. So it's anytime you're asked to solve an equation, it implies there's an unknown number, a variable, and you want to find out what that value is. Now, as I look at there's 5 different equations here. One thing I want to notice, or one thing I want you to notice, is they all have the same structure. They are all either a number equal to another number times a variable, or it might be written in the flipped, where the px is on the other side and the q is on the other side. And that doesn't matter. Don't let things like that throw you. Oops, I'm not even on the screen. All right, so I notice all of these equations are some number times a variable equal to another number. And we saw in the previous activity, these could be solved by whatever was multiplying the variable. You needed to divide both sides by that number. That number multiplying the variable has a special name. It's called coefficient, and we'll get to that later. But anyhow, let's start looking at these equations. So my first equation, A 35 is equal to 7 times x. Well, to solve this equation, I need to know what 1x is, not what 7x is. So I'm simply going to divide both sides by 7. And I have been writing division this way. But now I want to think about this. Yeah, this 35 divided by 7, or 35 over 7 means 35 divided by 7. So I could have also written it this way. 35 divided by 7, that was, most of us know math facts, it's 5. And 7x divided by 7 is 1x. And again, I don't have to write the 1. If I see x all by itself, it's understood. It just means one of them. All right, so my solution here was 5 equals x, or x equals 5. Let's move on to the next one. 35 is equal to 11x. So again, I know what 11x's are, but I want to know what is 1x. So to accomplish that, I need to divide 11x by 11. And then to keep my equation true and balanced, I'm going to divide the other side by 11 as well. So 11 divided by 11 is 1x. And on the left side, I have 35 divided by 11. Now, I know that this means 35 divided by 11. But if I were to write that like this, it looks like an unfinished problem, 35 divided by 11. So there's a couple things I could do. I could go ahead and do the division here, and I can think of this as an improper fraction, and I can think 11 goes into 35, let's see, 3 times. 3 times 11 is 35, so that leaves a remainder of 2. So I could write it as a mixed number. That makes me actually a little more comfortable. I could do decimal division, but why complicate things? So this is my solution. I could leave it as x equals 35/11. We leave answers as improper fractions more and more as we go on further in math and into algebra. But for now, we can convert that to a mixed number. All right, let's move on to C. So C, again, has that same structure. This time it's just involving decimals. Don't let that throw you. I have 7x equals 7 7/10, or 7.7. I want to know what 1x equals, not 7x. So I'm going to divide that side by 7. But then I also have to divide the other side by 7. So 7 divided by 7 is 1. That leaves me with 1x. It's exactly what I want. And then on the right side, I have 7.7 over 7, which is the same thing as 7.7 divided by 7. So this is not as tricky as it seems if you even think about it in terms of long division. I've got 7.7 divided by 7. 7 goes into 7 once. 1 times 7, oops, I wrote my thing wrong. Do the subtraction, you're left with 0.7. Put my decimal point there. 7 goes into 7 one time, and I have no remainder. So x is equal to 1.1. If you're not comfortable working with the decimals, again, you can always convert this to a fraction. 7.7 is 7 7/10. If I convert this to an improper fraction, 7 times 10 is 70 plus 7 is 77. So I have 77/10 divided by 7. And if I do my keep change flip, I have 77/10 times 1 over 7. 77 and 7 can both be divided by 7. So I get 11 there and 1 there. And when I multiply straight across, I get 11/10, which is 1.1. Yeah, maybe a little bit more complicated. I guess it's your choice. Whatever you're more comfortable with as far as doing the arithmetic. Okay, now problem D. I have 0.3 times x is equal to 2.1, or 3/10 x is equal to 2 1/10. So again, don't let the decimals intimidate you. You want to get 1x. You want to know what 1x equals. You've got 3/10 of an x. So I'm going to divide, oops, not by 0.03. I'm going to divide both sides by 3/10. 3/10 divided by 3/10 just leaves x, 1x. Now I have 2.1 divided by 3/10. So again, lots of different ways I could do this. This one is, again, not too tricky to do as a long division problem. In this one, I would probably multiply both numbers by 10, because then this appears very easy. I know 21 divided by 3 is simply 7. So x equals 7. You could convert it to a fraction and do some fraction division. 2 1/10 divided by 3/10. Oops, no, divided by. Convert this to an improper fraction. 2 times 10 is 20, plus 1 is 21. So now I have 21/10 divided by 3/10. Then I could do my keep change flip. 21/10 times 10/3. 10 and 10 can both be divided by 10. 21 and 3 can both be divided by 3. And when all is said and done, I end up with 7 over 1, or just 7. Any way you do it, my solution is 7. All right, and that brings us to our last one, which is fractions. Well, fractions. So I have 2/5 is equal to 1/2 x. Again, don't forget that this is just this equation. A number is equal to another number times x. If I want to just have 1x, I need to divide both sides by whatever number p is. So this is no different. I have 2/5 is equal to 1/2 x. I want to get x all by itself. I'm going to divide both sides by 1/2. 1/2 divided by 1/2 is just 1, so I have 1x. And over here I have 2/5 divided by 1/2, which looks crazy, but we've done lots of problems like this. This is just 2/5 divided by 1/2. I do my keep change flip, so it's 2/5 times 2 over 1. And when I multiply straight across, I get 4/5. So I have 4/5 equals x. Now, this seems crazy, and when we're working with fractions like this, it's hard to intuitively know, does this answer seem reasonable? But again, I can always go back, substitute my solution in for x, and see if I get a true statement. If I substitute 4/5 in for x, is 1/2 times 4/5 going to be equal to 2/5? So let's try it. Let's try it in a different color marker. 1/2 times 4/5. 1 times 4 is 4. 2 times 5 is 10. So I get 4/10. And if I simplify this, divide the top and bottom by 2, I get 2/5. And that is what I should get if I did it correctly. So you can always go back and check your solutions by substituting them back into, I should circle it so you can see it, into the original equation and see if you get a true statement. All right.